I guess we should do a little bit of an introduction. Hi, my name's Emily Hoff. I'm a PhD candidate at Texas Tech, and today I'm going to be interviewing Dr. Ken Miller from Rutgers. He has been awarded the Francis P. Shepard Medal for Excellence in Marine Geology. And we have a few questions that we're going to go through and give him some time to talk about himself and the geology around and what you do. So the first of which um, is, do you want to give a little introduction to yourself, a little background?
Sure, I am. So I go by Ken, or it's like try to encourage my students, just call me Prof. Ken or Professor Ken, since they feel a little intimidated. I try not to intimidate my students. But I was a baby boomer, and I was influenced particularly during the Sputnik era by the undersea world of Jacques Cousteau, which you may have not heard about. It's a television show that ran from 1966 to 1977, and everybody wanted to be an oceanographer at that time. I actually started at the United States Naval Academy, and my
Oh,
incoming class of 1,500 students, 1,000 of them wanted to be oceanography majors. So I ended up at Rutgers, the State University of New Jersey. I'm finishing my undergraduate, and I studied geological sciences and took a course simply titled the Oceanography and Earth History. It was basically 102 geology taught by Dick Olson. And I was fascinated by paleoceanography and finding out how continental margins evolved through time, and especially this idea that sea level has changed by hundreds and hundreds of feet. And I ended up at Woods Hole Oceanographic Institution, and in a joint program with the Massachusetts Institute of Technology, MIT, in Woods Hole, Mass. I spent my time in Woods Hole, and my PhD thesis was on actually deep water history in the Cenozoic, and particularly in the Eocene to Oligocene, uh, about 55 million years ago. And I studied how deep water affected climate. And coming out, I was offered a job from Exxon Production Research Company of Exxon Corporation, working in a group under Peter Vail. And I ended up turning them down the job, but it would have been to put together sea level curves. But I ended up at Montardi Earth Observatory of Columbia University, where I was initially a research scientist, became a senior research scientist there, and where I started studying both deep water history and sea level change in the Cenozoic, going all the way from the past 66 million years up to the Holocene. And I sailed on leg 95 of then the deep sea drilling project. Okay, it's the next to last leg on the New Jersey continental margin drilling. And so I started a campaign back then. This was 1982. We started a campaign to study particularly the New Jersey coastal plain and continental shelf off of New Jersey and what we call the Baltimore Canyon Trough to understand a sea level change. And that campaign's still going on now, almost 40 years later. Um, One of my favorite stories is uh, I co-led an expedition in the submersible Alvin. So my dream, like some people dream of going to the moon. Some
mm,
people dream of flying an F-111. Okay. My dream is to go down in the Alvin. The submersible Alvin holds three people. If you've seen the movie Titanic, yeah,
mhm.
Alvin discovered the Titanic a few years, couple year before I dove in it. We dove on a continental slope off of New Jersey, and we did one dive. We got some really good push course, and that's another story. But we learned a lot from those. And the next dive on the way down, we basically crash landed into the bottom and lost all power.
Oh no, oh no.
I can't say the word that the head pilot, who was a very seasoned pilot, he was one of the best. He's unflappable. I would see people screaming in his face, and he'd be unflappable. And he turned around and in the darkness said a word I can't say here. Okay, but
Mm,
imagine what it was like. Oh,
yeah. Hmm.
and we were in the dark for a while, and darkest dark you can imagine. And eventually, he's just none of the systems will come on. Rebooted the system, the power came on, and we continued to dive. Okay. Yeah. So that's a little background. I ended up at Rutgers in 1988. I've been there ever since. I was very fortunate to be hired after 7 years at Lamont with tenure. And I spent my whole career at Rutgers, and we've continued. So another cute story is Greg Mountain and I have collected multi-channel seismic data on numerous cruises off of New Jersey. And one of the first cruises was one of the on the Maurice Ewing out of Lamont, the ship named after Doc Ewing. And on that cruise, I actually posted on the wall of the lab the Exxon roadmap of New Jersey. And everybody thought it was a huge hoot. It was funny, So I'm offshore driving a ship as a co-chief, and I'm using this map of the roads onshore. But it
Mhm.
pointed out that we could drill onshore and learn some of the same things that we were learning by going offshore. And it was a lot cheaper to drill offshore. So we eventually drilled with the Geordie's resolution on the outer shelf. That didn't work too well. We drilled on the slope. It worked really well. But in 2009, after over 20 years of planning, we eventually took a lift boat called the Cade offshore in New Jersey. They jacked it up out of the water. It was expedition of the then International Ocean Discovery Program uh, to sample off of New Jersey. And we ended up working all that stuff up and publishing a bunch of papers on it. So from all that work, we learned a lot about sea level, and that's what I love to talk about. But I'm also very interested in the evolution of climate.
Multifaceted researcher I can see. So with all of that being said, little background about what you've done. What is what is your most prized achievement in your career?
Well, providing a better understanding of, again, sea level change and its relationship to climate.
Hmm.
When the Vail curve came out in 1977, it was the standard that you would compare to. And of course, in the mid-Oligocene, some 30 million years ago, they had a sea level lowering of about 400 meters. Very hard to understand how you can do that. We worked in various proxies, not just in New Jersey, but also in deep sea Pacific oxygen isotope records. That's been a big achievement in 2020 is to integrate those two proxies and can show that sea level in the mid-Oligocene did fall. Peter Vail and his group got it right, but only by about 50, 55 meters. And it was due to building up of an Antarctic ice sheet that was probably as large, if not slightly larger than the modern one.
Hmm.
So understanding when those ice sheets grew and decayed. I'm a bit cheeky at times. I like to show up to Antarctic meetings and say, I'm going to tell you what Antarctic did by studying New Jersey and the bottom of the Pacific Ocean. Because the bottom of the Pacific Ocean gives us the oxygen isotope records we need the best, most, and of course, New Jersey tells us something about regional sea level. And that's what I think I'm most proud of. When I was a graduate student, the Antarctic ice sheet began 15 million years ago. Okay. As a postdoc, we were the ones that provided the data that showed that the big ice house began 34 million years ago in the Oligocene. But we've continued to push it back, and our most recent papers we are suggesting that there were fairly significant ice sheets even back in the so-called greenhouse world of the Eocene and in the Cretaceous. That's heresy to some people, but I think it will be proven true in the end. And so that kind of revamps how we look at climate in these past warm intervals. They certainly were warm. They were certainly different. They certainly did have high carbon dioxide. So we're all concerned about carbon dioxide. Yes, today it's at 425 parts per million. Back in the Eocene, you can say with a reasonable degree of certainty, we were over 1,000 parts per million. Okay, and the planet was warmer. But there were still ice sheets that came and went. So I think that that may be the legacy for my career at the end is that what was really one of those crazy ideas actually proved to be true.
That's very fun. All right. So with that being your most proud moment, were there any moments where you had challenges? I mean, obviously the submersible crashing and almost catastrophic failure seems like quite a setback, in at least the momentary. But were there any challenges or setbacks? Um,
So going to sea, I've done 9 cruises. It's always a challenge. And cruises are like being in the Army, as the old saying goes, or I was a Navy guy, right?
mm,
That there are long periods of boredom punctuated by moments of sheer terror. Yeah, crashing in the album Sheer Terror. But, serving as co-chief scientist on an ODP cruise like 150 is certainly the most challenging job in managing 25 very talented scientists, 25 very hardworking technicians, and they were all working under us, and we were the ones that had to help make it all mesh. That was more challenging. I was department chair for 9.5 years. It's a challenging job. Anybody that hears this will just laugh, okay? Go watch The Chair on Netflix. It's it's a challenging job, but nothing compared to being a co-chief of an ocean drilling program leg or an IODP leg. And so
mm.
that's your job is really challenging.
In the sense of like intellectually or just being separated or just being on the water specifically? I'm actually quite curious.
That's good. A good question. As a leader, that's where the real challenge is. But if you're just sailing for the very first time, you're spending 2 months at sea.
Mm,
And it seems very romantic for about 3 or 4 days, assuming you don't get seasick. Okay. We're assuming
yeah.
that. Okay.
Yeah.
Assuming you get through that. And everybody does get seasick. But, it's very stressful to be out there. They've done psychological studies after people's reaction after, 4 weeks at sea, 5 weeks at sea, 6 weeks at sea. In the military, you're trained to do that. That's your job, and hopefully you would adopt. But scientists, we're free spirits. Or a lot of us don't deal well with authority or with you have to do this at a certain time. Every
Hmm.
day, 7 days a week for 8 weeks. Okay.
Yeah.
Mealtime, yeah, they feed you your meals. Yeah, they'll do your laundry for you. But you're on basically 12 hours a day working. And
Mm.
yeah, you get some time in the gym, but everybody puts on the freshman 15, Okay, everybody, and then you lose it again because, by the way, after 6 weeks, the lettuce is gone.
Mm.
And so it's
Yeah.
a long time. It's nothing like what people that are going to sea for months at a time have to deal with, 6 months at sea. But it's still
Yeah.
challenging. And so that's part of it. But just being at sea, some people really love it. I still go to sea, but now I go for a week on, the Love Boat, with my
Mm.
wife on a cruise. That's a bit different. And you're
Yeah.
getting off almost every day. Here you're restricted. The exciting part, though, is that there's no place that you're going to get more data faster and new stuff, particularly when you're pulling core in an area nobody studied before. That was what was so exciting about
Yeah.
ocean drilling. And of course, in order to do ocean drilling, you have to go out and collect the seismic data to show where the sites are. You have to do a lot of those things. I always preferred being able to commute to my drill sites on land. I could come home at nights. There's an advantage.
Yeah. Sleep in your own bed.
Sleep in your own bed. You can balance the family. One of your questions, I guess, still coming up will be how do you
Yes.
balance the family? And
Hmm.
it's easier to do when you're at sea. Again, 8 weeks away is really tough on a family. So
Yeah. So with everything that you've done, I would hope that you have few regrets because you've done a lot of amazing work. But if you were to go back in time, is there anything that you would do differently?
in terms of science, I'm really happy how it all turned out. It was unexpectedly good.
Hmm.
My kids make fun of it when I publish the next sea level curve. They go, "Oh, this is what the fifth Miller curve, right?" Okay. It's not as good as the Vail curve. I got tough kids.
Uh,
But so in terms of science, nothing. And, I thought about this question you put before me, and it was like, if anything, one thing I think that we've seen in the past 10, 20 years is that people treat each other a little bit better. And if anything, I would have hoped, I think I try to treat people better. Okay. When I treat them well. But there's times I know, either when I was a co-chief or on a cruise, you're a little cranky and you say the unkind word, or maybe you're not as encouraging to another scientist, especially an early career scientist. We definitely, there was a lot of iron men and wooden ships approach to sciences. We'll come back to how, in particular, oceanography has changed. I mean, I sailed with the very first woman who ever sailed a U.S. oceanographic ship. I sailed with that person. Okay. That just
Yeah.
shows you generationally where we were. Okay?
Right. Yeah.
We talked about the map behind me and Marie Tharp. Okay. She didn't get full credit for that. I mean, it was Bruce Hazen's, you know. So I don't regret, but if I went back in time, I wish I could take some of my older self into the past to try and have that kind of personal perspectives.
Hmm. It's very personally reflective and a hard thing to do in the retrospect, obviously. But yeah, I think generationally, the world could definitely do with a lot more kindness. All right. So you mentioned this question earlier, but shifting into how, with everything that you've accomplished, and you've mentioned children as well, and a lovely boat with a wife, how do you manage your time, science versus living and breathing and having downtime?
So I have four kids, not five kids, four kids. I checked. I had to go check now. Four kids, four grandkids, nine cats, three dogs. Okay. And, and I work 50 hours a week, or I did at least
Mm,
50. When you're work is, it's not work. It's your hobby. And you have to learn to balance it. There's some weeks you have to work 55 hours a week, but you also have to learn to take the time, and you have to balance the science. You have to balance the teaching. I love to teach. Okay. I overteach, as everyone says. I teach an extra course, and I don't have to teach marine geology this semester. I'm doing it for fun. But
mm,
I have to be aware that I have other things to take care of. You have to make time for the family. And one thing I thought about this, we traveled extensively for work, and I bring some of the kids along. We went to Freiburg, Germany, and Paris, for a ODP planning meeting. But we managed then to take a week off to go skiing. And
mm,
we eventually bought a place in Colorado so we could have the family out there 2, 3 weeks a year. And so that was more family. Still work, you had to come back at 4 o'clock when you're done skiing and take care of all the emails and,
mm.
edit those papers and things like that. But it was a way that, the family was together, and we would do things. And you also have to take care of yourself. I mean, it's real easy to fall into not exercising, or eating too much, drinking too much, which everybody can do. You have to work at maintaining your own physical health. And I think that's really important too. So I always respect people. Hey, at lunchtime, I'm going out for a run. Now I cycle. I can't run anymore. My knees finally gave out. But I mean,
Mm.
that's also part of it. You have to balance your family. You have to balance your research. You have to balance your teaching, and also any any service that you do, which can be really important, but sometimes you can overdo it. So gotta learn to say
Yeah.
no.
Ooh, that is definitely something I feel a lot of people need to have a little bit more practice in saying no. I think a lot of it comes down to priorities. Like you have to identify the priorities in your life and highlight them when they need to be prioritized, kind of deal. Obviously, being a grad student, I've learned a lot about priorities and trying to manage them.
Wh- It depends on what you want to do with your career, and I'm going to talk almost off the record now, just to say, like, my advice is that if you're going for an R1 school to be a professor at, It's write papers, write papers, write papers. If you're planning to go to a teaching school, yes, you got to get experience of really, and it may not be at the school you're at. You may moonlight. Some of them, I moonlighted when I was in Woods Hole. I taught for the
Mm,
Sea Education Association. I taught marine geology. And I did it with a few other people who did the biology side, and Randy Osman, who ran the field program. We had a great time. And that was my moonlighting. And when I
mm,
was working at Lamont, I was moonlighting teaching at Rutgers. Okay. So yeah, you had to keep an eye on what you want to do. And if you want to, a lot of people want to go work in industry. That's great. And they want to eventually, maybe someday, teach on the side. That's another good career. So you always can encourage people to get some teaching experience.
yeah. So, since you're a researcher, a family man, you sail, you have many hobbies, I can tell. Were there any unexpected skills that helped you with the jobs at hand?
Yeah, well, I was never officially classified as being having ADHD, although my kids will all tell me I did, and a couple of them were officially So
Mm,
obviously very energetic, very um, so in order to manage that, you learn coping skills, making lists, writing things down, of uh, focusing in what is important. And actually, I am known for being a notorious multitasker. And you can read a lot about multitasking. Is it good? Well, sometimes you have to. You
mm,
simply have to. And so I actually handle that well. But there's other times I have to say, look, control the urge to multitask and focus on the moment. Okay.
mhm,
And so again, sometimes I'm on the mountain or I'm on the bike, skiing or cycling. I try to put it all out of my mind. And I think the same thing sometimes when you're doing a job. If picking at the microscope, it's sometimes best not to think about the science, but to focus in on the bugs themselves that you're picking.
mhm.
So
Yeah, the blank slate, letting rest is just as important as exercise.
true.
Yeah, cool. Right. So with everything that you've done and taking rest, this is a good segue. Rest is important. How do you deal with the days that you have something to do, and you don't really necessarily want to do it, or you're not finding as much joy in what you're doing?
I still love doing science, and there's times, your paper's rejected. I had a paper rejected this week in geology, and it'll eventually come out, but you just got to put it on the side and say, let's move on and go on to the next. I love doing science. And I love interacting with people. I'm working from home today, and the work from home environment is good because I'm getting to see my wife and the dogs and hanging out here. And I'll make it more done. But I think it's really important to remember that science is best done with colleagues working in person. And so my, again, advice to anybody that would want to listen to this, my advice would be to always try to target at least 3 days a week in the lab, in interacting with people. And yeah,
Mm,
days of working from home, we've all learned from COVID days that you can get a lot done. But boy, the interactions during COVID that disappeared. Sometimes at COVID, when you got up and you're only looking forward to Zooms, it was a little tough. I think we all felt that way.
mhm.
But, going into Rutgers or going into a meeting, yeah, I'd look forward to it.
Yeah, I definitely also resonate with the sentiment that like collaborative science and or just like collaboration in general is for sure the way to go. Integration, collaboration, all of everything. The more the merrier.
There-
It's a saying for a reason.
There's nothing more exciting if we're here having this meeting right now and you say, oh, I had some data. Would you like to see it? And you showed it
Yeah.
to me. And I look at it for a second or two and go, well, that's really cool. Did you notice? You discuss.
Hmm.
And I love doing that. That's why I like working with students, working with hosts, working with colleagues. at all levels because you have
Hmm.
fun doing that.
Hmm. Fun. All right. So getting into our next segment, the future of geoscience society. Um, do you believe that geoscience, and I know you've mentioned this earlier, that specifically marine geology has changed, but geosciences in general, marine sciences in general, or more specifically, have they changed over the years? And also, do you see more change in the future coming?
When I first went to my first Geological Society of America meeting in 1978, I think it was, uh, I could count the number of women on my hands. I'm not exaggerating. Okay.
Mm.
Of course, now it's 55% women. So that's a huge change. And we already talked about uh, the contributions which weren't being made because they weren't allowed to participate. All right, that's change. Um, but also, it, the importance, and it ties into your next question coming up about outreach. We are more aware that we can't just be stamp collectors, that we can't just be doing our narrow uh, collection of data and writing of papers, that we have to be able to tell people why this is important. And also being able to be as broad as possible. The one thing of being a professor at an R1 university, yes, you're niched down into a kind of, but no one was around to answer questions about the earthquake that happened last year in New Jersey. So I became this quote seismologist. I, I can know P wave from an S wave, but not that much more. Okay. But you learn to communicate with people and find out, and we are experts. We have been trained, and we should be able to be trained to discuss as broadly as possible geoscience with people.
Mhm. Yeah, I mean, geology specifically, I refer to a multitude of ways, but in my favorite way is the science of all sciences. It's really a combination of physics, biology, if you are looking into that kind of things, geology, geochemistry. I mean, you uh, have mentioned today you've done seismic. I know you do carbon isotopes as well, combining it into a geologic perspective. And so, like, for sure, integration of many, many sciences, geology is, which is very fun.
The late John Slater, who did the thermal curves of ocean crust, very brilliant geophysicist, asked me at my defense. He said exactly what you said. You're doing geophysics, you're doing chemistry, you're doing this. And he says, what the heck are you anyway? And I looked at him and I said, John, I'm a stratigrapher. Oh, paleontology. I'm a stratigrapher. Stratigraphers always done that. They work with the structural geologists,
Mhm.
the paleontologists, because we have to take the rock record and sediment record and tell the history of the earth from those. And in order to do that, you have to go into all those disciplines. So you're quite correct.
Yeah. Um, so you talked about societal differences with women becoming more important. But have you specifically, like, in more recent years, used better and newer technologies or tools? I actually am currently writing a paper about a new tool possibly that we could use for sea level change. So I'm curious your perspective of these changes as well.
Well, that's always the key, and that's why you need to continue to work with uh, people coming up. We now call them early career researchers, uh, people who have different backgrounds and different expertise, and you have to, obviously right now AI is all the buzz, okay? But, fairly, we've been using, now I couldn't spell GPR 10 years ago. I kind of knew what it was and all that. And also RTK, which is real-time kinematic. RTK, I didn't know what, still couldn't say. But these are new technologies in the sense RTK is where instead of a stadia rod, you're getting centimeter scale topography in real time. Okay. And when you're doing things like beach surveys, it is the new standard. But then again, we found that we can get drones now to do the same thing with almost when they're registered to the RTK that we can get centimeter scale topography. Hey, when it was only 20 years ago that in order to get that kind of information, you had to go into the waves and hold a stadia rod. Okay.
Mm,
You can now get information on the beach with real good, really excellent precision. So I can't do that. I work with a former PhD who's now a research professor who knows that technology. He's also learned from Bob Kopp here at Rutgers some Bayesian statistics. So we are applying Bayesian statistics. Some people would snub their nose and go, "Oh, they're just being fashionable." No, we're using the latest tool. We're using the latest statistical tools, Bayesian statistics, to really understand and put some real error bars on those sea level curves.
mm,
A cynic would say our sea level curves are made up because we're using benthic forearms or paleo depths, and that's an art. It really is. It's not, it's almost not quite, are the benthic forearms telling you the depths that you think they are? Well, in the marsh environments, as the late uh, David Scott said, he first published it. He says, yes, you can get centimeter scale resolution, and you can. Okay. But that technology, did that with benthic forehands back with Medioli in the 1990s. Ben Horton came along with his students, have done precise marsh stratigraphies, but they took it to the next level with the proper making sure all these datum levels are properly registered and all that. And so the technology really is driving what seems like the same data set from the 70s or the 90s or even the aughts is not the same. We're getting much better quality data and things like sea level change.
mhm. Yeah, I agree as well. That's a integration of multiple different tools into one study is the best way, in my opinion, of, having a temporal to non-unique is the best science. All right, so we kind of hopped into both outreach, but do you think that more specifically, are there things that we could do as scientists, as geoscientists or scientists in general, that we could do a better job at to inform the non-geologists?
We are doing a better job than we used to. Okay.
Hmm.
Geologists were just people with hammers to hit rocks, right? That's kind of what
Sometimes we still are.
as we still are. Uh, we are getting a message out with sea level change. We're getting a message out with bringing paleoclimate, past climates into the future equation. Uh, I think people, as soon as something bad happens, they do run to the seismologist. Well, how do we explain this earthquake? Well, we can't predict earthquakes, but we can uh, give some much better answers as to what's going on to people, and specifically here in New Jersey, where people never worried about them. We've had uh, several minor ones, okay? But we are able to communicate that. And I think it's really important to do that. And so I think when I was a graduate student and then a postdoc, no one was trained in that. And I remember meeting the New York weatherman at the basement of Lamont Hall as a postdoc because none of the other faculty and researchers wanted to talk with him. And it had to do with the fact that we had a 70-degree day in February in Palisades, New York. Okay. Nobody wanted to talk to him. Lloyd Lindsay Young was his name. And this meteorologist just want to know, is climate changing or humans doing it? Well, nobody wanted to go out on a limb and say anything. Uh, Back then, this was right when Jim Hansen was reaching out to Congress, okay, in the 1980s and saying, yes, we are changing climate. And that became a political issue. I think we need to respect our roles as scientists and present the best estimates we have. We should try. We're still human beings. So some of us will still be political, but in general, my approach in dealing with sea levels is a very important climate component. If if someone is either of one side or the other, R or a D, and they want to talk about sea level change. One is going to use it as a sword one way, and one's going to use it as a sword the other way. Okay, often. And so you want to be very careful and not over exaggerate it. But we can do that and give them a good answer. And I think that that's where people, I've reached out with press conferences. I've been in hundreds, literal hundreds of citizen meetings. Okay. And at the end, they said, "Oh, that was really balanced." And I think that that should be the goal of the scientist, is to provide balance. People can make their own decisions based upon the facts as we can outline it for them and the best estimates that we can give. So I took that as one of the biggest compliments that I ever get, is that that was really balanced talk.
Well, after as many years as you've been working and obviously perfected the way of speaking about science over all of these experiences, I think a well deserved. I mean, obviously you're very charismatic and you seem very knowledgeable from the very brief interactions that we've had. And I think you said something earlier that sparked a thought in my brain of we have new scientists doing new science, but I think there's importance to integrate the 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 foundational geology to understand where it came from into now understanding this new science is really important, and all of the steps in between, because those intermediate steps that we take to understand science just furthers our knowledge, how we can improve it even further. We started from here, we're here now, and there's steps still to be made. All right.
Don't want to deify the past. We don't want to deify Darwin. We don't want to deify, well, one of my favorites, Roderick Murchison. And sometimes you could say, talking about dead old white men, because most of them were white, most of them were men, uh, with a few exceptions. And I keep bringing Marie Tharp up because it's in my background. But at the same time, how people do have to know that there's thoughts evolve, our data sets evolve, but humans have thought about these problems for a while, and we can learn from what people did in the past in terms of their thought processes. And so a little history of science is always important in my classes. And I almost have to apologize again. Well, mostly I'm talking about, you know, uh, dead white men, but it's also very important to make sure that you recognize the contributions of everyone. There's obviously an important trend to recognize the contributions, let's say, of the areas around it when we're in native lands. We live in an area which is populated by the Lenni Lenape, and it's important to recognize that from then until now, there's been a natural history of the area that I study, which is mostly New Jersey and it's offshore. The early studies in the offshore are very important. They got a lot of things right. They got a lot of things wrong, and we've evolved. But understanding where they came from is important.
Mm-hmm. Exactly. All right. So for our last but not least question, with the challenges in getting a job, whether that be teaching in industry, consulting, etc., because geology opens so many doors. Um, why should one consider doing geology?
I think you some started off by saying bringing together so many disciplines to
Mm,
explain our natural environment. Okay. And so, in terms of jobs, we have 100% job placement with environmental firms. We are New Jersey,
mm,
but no, nationally also, geologists are doing very well in environmental firms, environmental engineering firms, and such. And they used to be really not very good jobs. They've gotten much better. The pay's gotten better. So our average undergraduate starting in the 50s, and we're having really good placement. And we do train them pretty well at Rutgers, but that's a good start. The master's degree is certainly a sweet spot for both employment and working in things beyond uh, the local environmental industry, whether it be in NGOs, government. And again, we've done very well with our masters going off and doing various things like working in Washington, D.C., or working in graduate programs to help run things. And so the the master's degree is a technical proficiency degree, and that's why to encourage students, that's a good sweet spot. If you want to do research, though, you have to get a PhD. And there are still jobs now. 6 months from now, who knows where we're going? I suspect it's not going to be as grim as it looked in January, February, and March. Okay.
Mm.
Which was really bad, especially when you talk about cutting National Science Foundation budget by 66%. Where we end up after all this at the end of the year, I suspect will be not nearly as draconian. Um, but in some fields, we have a very large planetary component in our department. And those working in soft money and not directly for NASA are directly impacted by these changes. And it's going to hurt science in the United States. I believe AGU's abstracts, from what I heard through the rumor mill, are down 60%.
Wow.
They're getting about they're getting about a third of what they were getting.
Mm-hmm.
So, you know, what that may mean to the person that's a first year student in a university is opportunity. Okay. Because people will leave the field and then there will be opportunities. Um, other than the collapse of the oil industry in 1980, um, I there still have been jobs. In terms of academic positions, they've always been very, as the British would say, very dear to come across. Okay. And yes, I would caution someone who wants to become a professor in an R1 research university or at a teaching university that they have to persevere. But if they're good at what they do, good at teaching or good at research, persevering uh, may mean an uncertain future for quite a while. But eventually, I think they'll succeed if they're good at what they do. So I would be not totally discouraging even of that. But as far as if you want to get in and get dirty and go out into the field and or even work in a lab and collect data, there's still plenty of jobs out there that have the need or a scientist. Remember, earth scientists are the best trained environmental scientists there are out there for the reasons you just said, because we've had to go through not just environmental science, and they're trained also in basic chemistry. We are dealing with problems of the earth that are specific. We solve problems. Okay. And I think there's still very good opportunities for geoscientists.
I agree. I love geology. There's nothing that I would replace my passion with outside of geology. I mean, you've been doing this for a long while. And I mean, I'm at the forefront of my career, fingers crossed. And I think a unique thing about geologists is that they are, like you said, spirited people. And so regardless of hard times or bad times like crashes in oil, that we definitely do persevere as a general population. And we always find there's not oil jobs, we go into consulting or we find another niche to fill just because I think geologists are pretty high rate and high standard scientists. But cool. Awesome. Thank you so much for chatting with me. This was a very fun experience and congrats on the medal. You've
Thank you.
obviously done such great science. Will you be at GSA to physically?
I will be
Nice.
there to physically.
Lovely. I will also be there, so we will be able to meet in person, which will be very fun.
I'm also a board member of the Cushman Foundation for Formidable Research. So I actually fly out Saturday or Friday to be there Saturday for a board meeting.
Hmm.
And there's a booth there that I spend some time at. And we have a booth, Rutgers also, that I spend some time at. And then, so I'm there for the meeting, you know, it's not just for the award. I love GSA. That's the other thing. I really
Yes.
do love GSA.
Yeah.
AGU, I like. It's sometimes too big a meeting, too overpowering. Okay. And you don't see many pictures of rocks. What
Mm.
I love about geology at GSA is I can go to a talk and I will see pictures of outcrops. I will see pictures of cores. I will see pictures of rocks and sediments. Okay. I like squiggly lines. Don't get me wrong, but I like GSA.